Today we are starting to study the subject physics, where we start studying the chapter mechanical properties of the solid. Here in our screen we see some pictures where hair crunches, rubber band, spring, balloon, bottle, copper wire, cardboard, office paper, steel tin cans. Where hair crunches, rubber band, spring, balloon have some different properties, where when some stretching the rubber and releasing the stretching force, it will take its original shape, same as in case of hair crunches. And in the case of spring, when we will compress the spring and release the compressive force, it will take its original shape, size. And in case balloon, when we will blow the air inside the balloon, it will change its size, and we will release that air, it will take its original size. But in bottle, when we will twist the bottle, it will don't take its original shape. And bending of copper wire, it will don't take its original size, original shape. So now how we can know these properties? Actually, it will study in this chapter, where first point comes to the solids. Solids means what? Solid are made up of atom or group of atom placed in definite geometrical arrangement. So solid has definite shape and size. And external force means pull type force or push type force, where in below picture one rubber band is stretched, where pull type force is used to stretching this rubber, and another image is push type force. One cylinder is pushed or compressed. This force is known as external force. And restoring force means what? When we will release this stretching force, the material or rubber will take its original size and shape. Means it has some internal restoring force. Due to that internal restoring force, it will take its original size and shape. But another case is where we'll compress this cylinder, it will don't take its original size and shape. Due to that external force, the body will change its size and shape. So that force is known as deforming force. Means body or material is get deformed. So the definition of deforming force is when a force applied to a solid, the size or shape or both change due to the change in relative position of molecule. Such force is called as deforming force. And deformation is a change in shape of a size or both of the body due to external force, called as an deformation. Now we study the elasticity and what is plasticity. Where elasticity means what? If body regain its original shape and size after removal of deforming force, is called as an elastic body, and property is called as an elasticity. As in last side, when rubber band is stretched and releasing its force, it will take its original size and shape. Means this material is called as an elastic material, and this property called as an elasticity. And another material is where bottle will twisted, and after that it will don't take its original size and shape. Means this property is known as an plasticity. So the definition of elasticity, once again, if a body regain its original shape and size after removal of deforming force, is called an elastic body, and property known as an elasticity. What is mean by perfectly elastic? Perfectly elastic means what? When body will regain its original shape and size at instant of removal of deforming force. Means it don't take time to take its original size and shape after removal of deforming force. It will take instant of a time its original size and shape. So that property that material known as an perfectly elastic. And plasticity means if a body does not regain its original shape and size and retain its altered shape or size upon removal of reforming force is called as an plastic body, and the property is known as plasticity. After that we come to the next point, which is the stress and strain. Stress means what? When we'll now stress and strain. The first point, stress. The elastic property of a body are described in terms of stress and strain. When a body gets deformed under an applied force, restoring force are set up internally inside that body. They oppose change in shape or size of the body. When body is equilibrium in altered shape or size, deforming force and restoring force are equal and opposite. So the definition of the stress is internal restoring force per unit area of the body is called as a stress. Here stress is the ratio of deforming force per unit area. Deforming force is known by F, area is equal to A. So F is the internal restoring force or external applied deforming force. Both the quantities are the same or equal. The stress has unit of Newton per meter square and also known by the Pascal. After that we come to the point strain. Strain means what? Strain is a measure of deformation of the body. When two equal and opposite forces are applied to an elastic body, there is a change in dimension of the body. Then this change is known by the strain. Strain is defined as a ratio of change in dimension of body to its original dimension, and both the quantities has same unit, so it has cancelled, so strain has no units. And there are three types of stress and corresponding strains. Now we'll study. First point is the tensile stress, is also known as longitudinal stress and tensile strain. Now suppose a force F is applied along a length of a wire or perpendicular to the cross section of a wire. This produces an elongation of the wire and the length of the wire increase accordingly. The figure 6.1a, where it has shown the length of wire is L and the force perpendicular to the cross section of the wire F, then it will change its original length, change to delta L. This is known as a tensile stress, force per unit area of the wire, and tensile strain is the change in dimension to the original dimension. Same, what is meant by compressive stress means when a rod is pushed at two ends equal and opposite forces, its length decreases. The restoring force per unit area is called as compressive stress. Compressive stress means what? Applied force or deforming force divided by area of that rod cross section, and that compressive strain is the change in dimension to original dimension. Where tensile stress, pull type forces used, and in compressive force, push type forces, where length is increased, here length is decreased. The main difference between the tensile stress and compressive stress, this both known as a longitudinal stress, because it both are related to the length of material, and the property known as tensile strain is a change in length to original length. After that we come to the point volumetric stress and volumetric strain. It is related to volume of material. Now let force F be a force acting perpendicular to the entire surface of the body. It acts normally and uniformly all over the surface of the area A of the body. Such a stress which produces change in size but no change in shape is called as an volumetric stress. Here in both diagram, when the force F is applied perpendicular to the area of that body, P type forces, then it will change its original size V to V dash. Then so volumetric stress is a force divided by area, and the volumetric stress produce change in size without change in shape of body is called as an hydraulic or hydrostatic volume stress. After that we come to the volume strain. Volume strain means the deforming force acting on perpendicular to the entire surface of the body produce a volume strain. Let V be the original volume and delta V be the change in volume, where V dash and V. After that we come to the next point, is a third point, is a shearing stress and shearing strain. Now in shearing stress, let F be the tangential force acting on the surface area A. This force produces change in shape of the body without changing the size is known as an shearing stress. Shearing stress is a tangential force to the area. And what is meant by tangential force? Tangential force is a parallel to the top and the bottom surface of the block. Tangential force is a parallel to the top and bottom surface of the block, and the restoring force per unit area developed due to the applied tangential force is called as a shearing stress and tangential stress. And the shearing strain is a change in length to original length, means change in shape to original shape. It is a ratio of change in shape to original shape. Most important difference in between these 3 points is in tensile stress and longitudinal stress both size and shapes are changed, but in volumetric stress only size is changed, no change in shape. But in shearing stress the shape is changed without changing of size. It is the most important and difference between these 3 points. After that we come to the one important note which is related to volumetric stress. It is when a balloon is filled with air at a high pressure, it will experience a force from within. This is also known as volume stress, and it tries to expand the balloon and change its size without changing shape. When the volume stress exceeds the limit of bulk elasticity, then balloon explodes. Means when we blow the air inside the balloon, then the wall of balloon experience some force. Due to that stress is known as volume stress, and it tries to expand the balloon without changing its shape, only change in its size. Means in volume stress it's change in only size without changing the shape, and when balloon gets exceeds its limits of bulk elasticity, balloon explodes. And similarly a gas cylinder explodes when a pressure inside it exceeds the limit of bulk elasticity of its material. And the third example is the submarine, when submerged under water is under volume stress. These all 3 example of volume stresses. After that we come to the point Hooke's law. What statement of Hooke's law is a within elastic limit stress is directly proportional to strain. Within elastic limit stress is directly proportional to strain. What is mean by elastic limit? Elastic limit means the maximum value of stress up to which stress is directly proportional to strain is called as an elastic limit. Where in this graph at this point, maximum point, stress is directly proportional to strain. This maximum point is known as an elastic limit, and the ratio of stress to corresponding strain is known as a stress is directly proportional to strain. Then ratio of stress to strain is constant. This constant is known as modulus of elasticity. So modulus of elasticity of a material, it is the ratio of stress to corresponding strain. It is defined as the slope of stress strain curve in elastic deformation region and depends on the nature of the material. It is also the slope of stress strain curve of elastic deformation region depends on the nature of the material. After that we come to the point elastic modulus. In last slide we studied this constant modulus of elasticity, where three types of modulus of elasticity. Now we will start with this. First is a Young's modulus. Young's modulus means what? It is a modulus of elasticity related to change in length of an object like a metal wire, rod, beam, etc. due to applied deforming force. Means when object is under the deforming force, it will change its length. When it will change its length, when it is related to change in length, then this is known as Young's modulus. So first upon, the longitudinal stress is applied force per unit area, force is F, applied force is F, area is equal to A, applied force is equal to mass into gravity mg, and area is pi r square. And same longitudinal strain is a change in length to original length, change in length is small n, original length is capital N. So Young's modulus is a ratio of longitudinal stress to longitudinal strain. As we know, the Hooke's law is related to stress per unit strain is equal to constant. Means stress to the corresponding strain is equal to constant. So stress is related to change due to the change in length. So longitudinal stress to the longitudinal strain is Young's modulus. So longitudinal stress is mg divided by pi r square, to the longitudinal strain is L divided by capital L. So y is equal to mg capital L divided by pi r square small l, and the SI unit of Young's modulus is Newton per meter square, and its dimensionless are L minus 1 m1 t minus 2. After that, we come to the one important note point is the Young's modulus indicates the resistance of an elastic solid to elongation or compression. Young's modulus means what? Here one table, Young's modulus of some familiar materials are given here, and Young's modulus Y, some values are given here. We will take some example as a copper is 11 and gold is 8.1 Young's modulus Pascal. Means copper takes more force, more tensile stress for the same strain. Means Young's modulus of material is useful for characterization of object subjected to compression or tension. After that, we came to the point bulk modulus. Bulk modulus, it is related to change in volume. It is a modulus of elasticity related to change in volume of an object due to applied deforming force. So bulk modulus is defined as the ratio of volume stress to volume strain, and bulk modulus is known by capital K. Volume stress is dP and volume strain is dV by V. So V is equal to dP by dV, and SI unit of bulk modulus is Newton per meter square, same dimension of Kr L minus 1 m1 t raised to minus 2, where the some values of material of bulk modulus of some familiar materials are lead, brass, glass, aluminum, silver, copper, steel, gold, and the values are given here. Steel has 16, silver has 10. Where bulk modulus measures the resistance offered by gas, liquid or solid while attempt is made to change their volume. Means suppose one material steel, take the example of steel and silver, then steel has take more resistance offered to change their volume, and silver gives less resistance to change its volume. Here one note point is the bulk modulus of water is 2.18 into 10 raised to 8 Pascal, and its compressibility is 45.8 into 10 raised to minus 11 Pascal inverse. So material with small bulk modulus and large compressibility are easier to compress. Material with small bulk modulus, small bulk modulus value and the large compressibility value, then easy to compress, which is important point. After that, the third modulus of elasticity is a modulus of rigidity. Modulus of elasticity related to change in shape of an object is called as a rigidity modulus, where one example of box diagram is given here. The modulus of rigidity and tangential force F and shear strain theta. Tangential force F is applied to the original box. After that, it will change its shape to dotted line box. Then its shear strain is theta. So the force F and minus F are parallel to the cross section. F and minus F parallel to the cross section. This is different than the tensile stress, where the force is normal to the cross section, which is different from the tensile stress. After that, the shear modulus or modulus of rigidity, it is defined as the ratio of shear stress to the shear strain within elastic limit. So shear stress divided by shear strain is F by A divided by theta is equal to F A theta. So the some values of rigidity modulus of some material is given here, as lead has 0.6, silver has 0.27, 2.7, golden has 2.9, brass has 3.5, copper has 4.0, etc. Means rigidity modulus indicate resistance offered by solid to change its shape. What will actually shear modulus? The rigidity modulus indicates resistance offered by solid to change its shape. Means, as we take the example, steel has 8.3 value and brass has 3.5, then steel has high resistance comparing to the brass material to change its shape. After that, we come to the point, it is a Poisson's ratio. Poisson's ratio, it is a, suppose a wire is fixed at one end and a force is applied at its free end, so that the wire gets stretched, length of wire increases and at the same time its diameter decreases. Length increases, diameter decreases. That is, the wire become longer and thinner. Wire become longer and thinner. Then so the ratio of change in dimension to original dimension in the direction of applied force is linear strain, while the ratio of change in dimension to original dimension in direction perpendicular to applied force is called as lateral strain. And within elastic limit, the ratio of lateral strain to the linear strain is called as a Poisson's ratio. So Poisson's ratio is the ratio of lateral strain to linear strain. Lateral strain is D by capital D and linear strain is small l divided by original capital L. So D into delta D into capital L divided by capital D into small l. It is a Poisson's ratio.